Okay, I just want to review this testing of the pulse output. In this case, we're doing, this is an FS220, and we're using it as a totalizer. So I just want to review this again because still get a lot of questions. So if you notice that the plus of my power source, and my power source, in case you're wondering, is just a 9-volt battery, which actually is not actually reading completely 9 volts. It's a little worn down. I have a resistor. It's like a 450. All right, let me double check. Yeah, it's about 450 ohms. It's just suitable for the test. And I have the negative lead of my battery going to this resistor, and the resistor is going to number 9. So plus of the power source goes to 8, 9 goes to the resistor. That's my voltage drop. That's how I'm going to actually accumulate counts. And then I have my voltmeter across the resistor. And if you notice, let me switch my thing around. It's nice and slow, where I can read the total voltage of the battery, and then it switches to 0. And this is DC volts. And let me show you why. So first I got to go to Setup, Inputs and Outputs, Channel 4, Operation Mode, set the pulse, and for totalizer I'm using volume flow. My flow direction is positive. Set up my units as US gallons, for instance. Now the way I have this set, you'll only get a pulse every 100 gallons, but you could set this however you want. And I only want one pulse for each accumulation. My pulse width units will remain in seconds. Now my pulse width, just for this test, I set it to a pretty big number. I set it for 2 seconds. It's actually set for 2.1 seconds. And that gives me enough time to see the transition when I do my simulation. Polarity, I'm not going to worry about that. So when you get a pulse, it could go low or it could go high, depending on what you want. Okay, I don't need to set up the other stuff, so I'm going to go out of this. Going to find maintenance and diagnostics. Going to find simulation. Inputs and outputs. Channel 4. Enable the simulation mode. And to make this relatively slow, I only chose like 100 pulses per second. And by doing that, I get these nice transitions between 0 volts and whatever the battery reads. Just remember, when you're done with your test, you're going to want to go back and set your pulse width narrow enough so that if your frequency gets pretty high, your pulse width is not staying on too long. Otherwise, each one pulse width will run into the next pulse width. So you can set that to as low as your PLC or whatever you're hooking up to the meter will be able to still capture. And that's pretty much it. This is a good way to see that you're getting the clean transition for pulses just using a voltmeter.